Okay, I'm going to show you why this is true. And there's a bunch of key ideas. One is that if tangent inverse x is y, tangent y is equal to x. And again, what we're saying is that this is our ratio and that y is our angle. So the tangent of a ratio is an angle. The tangent of an angle is that same ratio. And since it's a ratio, that's x over 1 and opposite over adjacent. Okay. The second is if f of y equal x, then if we take the derivative with respect to x of y, we get that the derivative of one side is equal to the derivative of the other side. So in other words, if two things are equal, so are their derivatives. Now, related to that is implicit differentiation. If we take a derivative with respect to x of something whose variable is y, we treat it as f prime of y, so prime there, times the derivative of the inside. So that's f prime of y equals dy dx. And I'm just going to write dy dx as y prime. These are the same thing, just shorthand. That's easier to write. Finally, if the tangent of y equals x, we think of it as x over 1. So opposite side would be x. The adjacent side would be 1. Once you're comfortable with these ideas, this comes fairly quickly. So we'll start here. We have tangent inverse x equals y. That tells us that the tangent of y equals x. Now, why are we doing this? Well, when we take derivatives, we know this derivative, and we can solve for the unknown. Here's what I mean. So we have the derivative of the tangent of y is equal to the derivative of x. Because two things are equal, so are their derivatives. Well, this side is easy. That's just 1. Now this is going to be the derivative of the tangent, which is secant squared of y, times the derivative of what's inside the tangent, which is y. So we don't know what that is. That's going to be our unknown. So in other words, we're going to have secant squared y times y prime is equal to 1. And what we're going to do is we're going to solve for that. Sorry, that's my phone in the background. I'm going to have to ignore that. So in other words, if we solve for y prime, we can find our derivative. So here's y prime. It's 1 over secant squared y. Okay, now, where does that, we need to figure out what's the secant squared y. Okay, and that's going to be our next page. So I'm just going to go over here to the next page. Okay, so this is where we were. Y prime was equal to secant squared y. And we need to find secant squared y using a triangle. Now this is a little bit out of left field, but I think you'll see where it comes from. And remember too that y prime is our derivative of y. Y was equal to the inverse tangent of x. So y prime is just the derivative of the tangent of x. Okay. So we need to find this. So think back to a triangle. Secant squared y, we're going to think of that as an angle. And so the secant is going to be, we have hypotenuse, opposite, adjacent. The secant is adjacent over hypotenuse. Oops, had that backwards. Hypotenuse over adjacent. So if we can solve this triangle, we can figure out what this is equal to. So let's see. So we want to solve this. So we recall that tangent of y is equal to x. That's from the first page. Now this is a ratio. So we get this is equal to x over 1. So x over 1 is going to be the tangent ratio. And that's going to be opposite over adjacent. So now we can plug this in. There's our x. There's our 1. Well, what's h? h is going to be x squared plus 1, right? Just the, I'm sorry, it's going to be the square root of x squared plus 1 using the Pythagorean. A squared plus b squared equals h squared. H is going to be the square root. So in other words, this is equal to opposite squared plus adjacent squared. Okay, so now I have this. So what's the secant? Hypotenuse over adjacent? Square root of x squared plus 1 over 1. Or just plain old square root x squared plus 1. Okay, so key secant y is equal to x squared plus 1. Now look what we have. Again, I'm going to go to the next page and summarize. We have y prime equals 1 over secant squared y. That's what we had here. We solve the triangle, and we have secant squared y equals square root 1 plus, I'm sorry, secant y is equal to 1 plus x squared. Oops. I should go back and do that. The secant of y is equal to opposite over adjacent. The secant of y is equal to that. Sorry, not secant squared, but we're going to do that. Okay, so, well, this is going to be 1 over square root x squared plus 1 squared. Well, that's just 1 over 1 plus x squared. So what do we have? We had the derivative of the tangent inverse. Here, let me do it this way. We have the tangent inverse of x equals y. Therefore, y prime equals the derivative of the tangent inverse of x. Well, we solve for y prime up there, and we get 1 over 1 plus x squared. So, quick summary, and we'll end. Started out here, tangent inverse of x equals y, tangent y equals x. So we went through implicit differentiation, and we realized that y prime equals secant squared y. Well, that leaves the question, what's secant squared y? Well, again, recopying that, we need to find that using the triangle. So we realize that the secant ratio, sorry for the mess there, hypotenuse over adjacent, h over adjacent. So we need to solve the triangle. So we went back and recalled that tangent y is equal to x. That's a ratio, a tangent ratio. That's x over 1. Opposite over adjacent. Opposite was the x, adjacent the 1. Well, that tells us how to find the hypotenuse. So we go through here, secant y is hypotenuse over adjacent. That's equal to square root x squared plus 1. So the secant y is x squared plus 1. Now we're just going to plug this back into here. I'll do that on the next page. Y prime is 1 over secant squared y. Secant y is equal to the square root. Plug that back in. X squared plus 1, we get that. And recapping right there. Okay, so that's the bottom line. That's why we get the derivative of the tangent is 1 over 1 plus x squared. And you try, for fun, try to show this. Do that on your own. And if you want, I can go over that in class. Thank you for your time.